Good afternoon, my name is Nikolay Ryzhikov, and this is Marat Surmashev. We've been dealing for 7 years with health IT, automation of medical services. We do it on Postgres using JSONB. It's been 5 years already. We've been doing it in clouds, in Dockers, as you may be scared to do, and today we'd like to give you a short introduction into JSONB. It's the data type which is present in Postgres, and it opens the whole world, allowing us to mix document database and relational database with good SQL, ACID, and so on and so forth. The masterclass is planned as a roundtable, as we sit together and do something together, but maybe we will do it in a push mode. We're going to show it to you. The repository with all codes are shared. You can do it once again from home, from Docker Compose, and let's start. We will speak about philosophy a little bit. What is JSONB, why it is needed, when to use it, and maybe not to use it, and you will help me maybe. Then we will have a getting started mode. We will upload some data from GitHub. We will study it a little bit, see them, and then go topic by topic. What are the trade-offs? What do we pay when we start using JSONB, and how much we should pay for it? Then we're going to see how to paste, how to modify binary JSON. We will see how to make a search on it, how to make a quick search using indexes, and then a small trick with aggregation, how it's possible to use JSON to return a rich reply from the database directly. That's the plan. Now let's discuss a little bit the philosophical questions, and let's meet each other a little bit. Who are the developers? Please raise your hands. Who is writing code in SQL? Who writes only SQL for service? Not many. So predominantly developers are here. Very good. Who develops systems with complicated subject area? Medicine, banking, accounting, and what others do? What do you do? Just with simple coding. Okay. Who's been operating JSONB completely in production? Well, one fourth maybe. And who is just considering? And others? What about others? Others just came here out of the curiosity. Okay. And my first question, which is very interesting for us, why JSONB is needed if we have tables, if we have a good database, Postgres, Oracle, why JSONB, why we need this all. And please, let's have your opinions. What are your reasons to consider this tool? Okay, let's go deeper. Why you wanted to install MongoDB, but you didn't want to, and you want to use Postgres? It's not possible to live without tables. Wonderful. Let's raise hands. Storing medical protocols. So why not to store them in a table? It's more convenient to have this full list. Okay, when data are changing, from behind, please. Storage of inhomogeneous data, voluntarily made data, unstructured. It's convenient to sterilize. Yes, we give the web. We have all these realized in JSON. We just move them backwards. What is non-relational? Relational. More ideas, please. Structuring of data. You place a trigger on the table and then you can use it. So for some reason it is needed. I have 3 key points why we really need such type of flexible framework. We are not always aware about the data. If we want to place something into the table should know about the data and data should know about the table. They have to match with each other. They are linked. In order to add new data, we need to add a column. If to change the table, we need to modify all the table. That's perfect in a perfect world, which is called a closed world, where we know everything in advance. We are able to make good tables. We can populate them. We can provide consistency. We can place data in other tables. But unfortunately, the reality is different. Something is more complicated, and we not always know all the data in our design time. For instance, the source can be external. We can get a bunch of external data, and it's very important for us to store them, other than understand them and just fail if we don't understand something. Secondly, systems become more and more dynamic, customized, and configurable. Our systems turn to some platforms which can be extended by users, adding new attributes, creating new instances, whatever. And in this point, we don't know where our user would go, what are his plans, and we know that tables have problems of this kind.
This is the first point. We do not always know our data. And the second of all is variability of the data. All the objects are unique and we understand it very well. So for us to cope with them, we need to model them and classify them and put them all into a specific form, in a specific scheme. So we put and add on the high level of abstraction. We create the table, notebook, and phones, and some online store. We make the table products. And there we have the columns with the type, category, something else, which tells us that in this table we have very variable data, and that's specialized and classified into different columns. And there is some inherent tables where the columns are used for the specific nodes and specific contexts. These tables are not very well used for the triple store, and JSONB can ignore the relevant fields. And they perform it in an elegant way. And the third thing that I specify for myself, daemon-driven design. Have you heard about this one? This is really good. Eric Evans, who read his book to the end, who heard about him, who has heard, and about the aggregates, domain-driven aggregates, the semantic aggregates. For those who haven't heard, they've developed it. All the developers make the objects or the structures, and they're quite tricky, like tree. We have the roots with the density, with the order, with the patient, and the list of the data which are not irrelevant, but they're added to these instances, so-called like value objects. So if we model it in that flat way, we will have like thousands of such tables and we will be completely lost. But if we group these tables into aggregates, we have tens and hundreds of such tables, so there is mental load is off the shoulders of the programmer. So in this case, we put the progress in the runtime. Those semantic aggregates are taken into account. The ORLM probably used. This abstraction is quite difficult to comprehend. Everything's curved. Object relational independence mismatch. I do not even know how to translate that. when the objects do not fit into the tables. So this is lots of suffering because of that. But this format of the JSONB format, which can be used when we give it to the web, and then we put it into the database simply and in an elegant way. So why this semantic rows is important, because we use these semantic aggregates. And you work it as a whole, as the grape of wine. So you put it all together into one spot. So JSON, this is why JSONB. So now let's proceed from the words, so from theory to practice. And for those who set it all up, we can repeat it, and Marat will show you something. So first, the getting started to show what JSONB is and how to work with it. So the practical task will be the following. We consider this to be the master class, and the people will come with their laptops. We have some structures here. For those who want to participate, I hope you have deployed everything which is needed, and now let's get to business. The JSONB in Postgres is a type of data which is developed to storage the JSONB data. This is done in the form of the line with a valid JSON specification 7159. So we can take sample line or thread, and instead we could be this something simplified or the full objects. It can include the full objects as well. It's important to know that here we have the figure 1 with JSONB format, not in line. We also have sent something without, but with a multi-line structure, nothing complicated. Through this JSON $sign, we can send it to JSONB. Yes, so you can write the division of this dollar signs. For instance, if you want to use the brackets inside the line, you can make the magic of using $2 sign. This is used in the storages, but here you can use the JSON literal and make it, if you copy JSON from internet and then you turn it into $$ sign of JSONB. So we know how to create JSONB. There is some function of JSONB pretty to look at it and to see what's inside of it. The other constructors, JSON built-array and others, we will look at it a bit later. So we know how to create the objects, so now we need to know how to operate them. And here in Progress we have 4 types of operates of the access, double arrow, and how to read them. The operator, starting with the minus from the right side, is one key or index, and the operator starting from the grid, they take into consideration the indexes. One arrow brings us back to the JSON-C format, and the double arrow brings us back to the meaning of the in-text context format, text format. So we have different options to receive the data. Let's look at one of the examples. Let's have the object which is called record and has the key and the figure number. So if we look back to the binary, one arrow giving the word key, we have the line value. This is the JSONB object. Why I want to know that? For you to build up indexes or complex text. This going back to this type is very important in this case. Thus, if we look at the nested key, we go back to key and JSONB nested value. If we go back with a double arrow, then value will come as a text visually, and the object will be also in the form of the text. It doesn't make any sense, but Sometimes it's very useful when we have very complex migrations, then it's easier for us to receive the JSON in the form of a line and to replace something with a regular one. But you usually do not do that, but sometimes it is useful. As for the grid and one line, the massive and it's been open along the way and is getting back to the JSONB text, and the double arrow brings us back to in the text format. With this, I think it's clear. Different operators operating in a different way. As an addition, we have two more functions for the access of JSONB objects. In the case when you have a record, or when you do not have the possibility to use the operator, we have JSON extract text and JSON extract, which are equivalent to the operator, the grid, and the grid like twice bigger. This is the analog in the function. How to create and read JSONB? We have a task, so we need to solve the problem. This difference in the problem, which is operated by the programmist, and the flat database. If, for instance, we want to upload the list of all the commits that's in the Postgres. GitHub at the public IP will provide it to us, and we will have a look what's inside of them. When we have a first look, we see that the models that have been operated by the developers of GitHub. We have HR representatives, the data, text, the mass, the errors. So you cannot see it right away that this model is, to make it model flat, it needs some time in order to write this RDM or tune the JSON. So what allows us to do the type JSONB? Inside we have the script, GitHub as such. So it's very simple. It's crazily simple. Doing the city page, for lit is the page. It reminds that in the search record with a name, and then it opens up this record to the number of texts, and then it's pasted. So you can make this script, and you can get this commits. The GitHub can be banned by IP server for some time. So let's create the table for the commits, and we'll have two columns: ID text, priority key, and the doc JSONB column. The relational commits is also here. We will not upload all the commits for those who loaded. They are loaded in the table commits underscore backup. So they're all backed up in the table. Here they are on our commits. So GitHub commits, we have them in our database. And they are not, that's the simple ones. What we can do with them, we can use the operators of the access operators and aggregators, and we can find the most active commit, which has the username. I will not be able to pronounce it, but very active one with the Postgres. This is Tom Lane, probably. Then we can find the person had the biggest number of commits per day. So we take the docs commit author date, and then we open mail, name and email, and then we group this data, and we will make the calculation. 48 commits. Tom Lane, in 2018 had 48 commits in the repository on the 26th of September. We also have some crazy script or request requiring is that using the usage of the keys of this data, and can show you how this data in homogeneous. With the attribute author has only 21 user, which is unusual. Do we have some other elements? TSBK. So practically every commit has a parent. So let's see what's been uploaded. These are the bits. So every user has a parent, they have element ID, and the author, not all of them. Oh, only one actually, which is very strange. Oh, you say commit author. Okay, we can see that. So with that query, we see what the keys have been used and what data we have. So the algorithm can be simple. You loaded some JSON, you use this tool, and then you see what fields you have. So the JSON can be used for the research of this external data in Postgres. So we've just seen how simple and nicely it can be done with the JSON, and how much we'll pay for that. Well, of course, it's not for free. First of all, the field JSONB, Postgres doesn't get any statistics, so the planner of the query doesn't know what to do with it. The queries cannot be effective unless you build up the index, which will compile the statistics for ourselves. So the JSON types, they have only few types, boolean and the number of lines, and the objects of the array. So we use some Postgres types, stz and such and such. We will not use them. You probably are used with how fast we can get to the field of JSON compared to the column. So now we will make an experiment and we'll compare, we'll make it in one table so everything is in the same place, and then comparison could be valid. So we'll do a regular JSONB column and JSON, which is in a line. So when you do the operation like with arrows, it parses it. Then we can simulate such structures like embedded structures, and we will compare it as well. So we'll have 4 comparison. First, the composite types, which will simulate our JSON attributes, and further on, unfortunately, we do not have recursive in composite and Postgres. So we need to create the hub in order to know how deep it is that. With JSON, it's not necessary. And then we create the table with a text column, JSONB, JSON, and our typed composite. So we create the table, and we start to paste something into this. Marat will share some words about JSON type. So some simple type with 100,000. So paste it. So we do this require on purpose so that this can throughout the whole table, and we'll take out this column from the table, and we didn't put the numeric into that. We sort of wrapped up the text, and things will decrease when comparison. So it will jump up a little bit, and it will take just a few milliseconds. Now we go to JSONB with one attribute, to take one attribute, and there are 40 of them. My notebook is a bit hot, but in average is probably 30% of that column. And let's go to JSON. Here, this time of parsing is constant, and it's added to it. It's twice slower than the previous one. Okay, let's put it in the 2 levels of embedding. Let's go to JSON. It's a little bit slow. Let's go to deeper. So you can load it and see it's about 0.1% that you pay for the success. So we go deeper to JSON and parsing. I have this embedded grep as well. JSONB. We go like 3 levels deeper. 43 milliseconds. And now we go to the T-type, and I was surprised that it takes more time to get into this. So maybe this arrow of the operator optimizes it, but if we generate the composite types that going in the same level, it will take us more time. But there is no arrow sign.
Let's discuss it afterwards. I'm not ready to answer. Okay, that was interesting also. To JSON command, and it was transformed to JSON. We looked at it, tens of percentage points you will pay. And another interesting thing, how much we will pay in terms of space. Let's make a few tables with a simple JSON and ID, similar structure of a flat table and our embedded type. Let's make these tables. Let's populate them. We populated the first one, the second one with similar data. Once again, you can play it back for yourself and take a look at it in more detail. And now we populate the third one. This is our magic function copied from Postgres, and let's have a look. Here we go, JSONB 23 meters. Just simple table is around 8 meters. The composite type 17. Unexpectedly big. I will ask colleague how come that we have such large numbers for a composite type. Basically, those ratios, if we did it flat, would significantly depend on the nature of your data. One big piece of text is different. Together with JSONB, we store all keys with every record. So the question about the ratio of keys to your data, if you have just numbers and long names of keys, it wouldn't be optimal. But as soon as you get a big text as a value, the value of keys will be lower. There's a JSON extension with trace to enum the keys, and they did it from Postgres Pro. Well, and the benefit is not so big as may seem. We're dealing with medicine, there are standards, and there are examples. For example, patient in JSON, 30% accounts for the keys in this system. The total length of keys versus the total size. Another unpleasant moment, if our tab goes over 2 kilobyte, it's going to be parsed, it's going to be toasted. We see here synthetic data which pretend for real ones. Observations with labs in some nothing went to toasts, visits, encounters, not so many in toasts, and about patients, almost a half of them are there. Unfortunately, I couldn't find anywhere how much we pay for toasts, but we still pay something because we should get them, encrypt them, unzip them. Well, you can take a look how much went for toasts. You can check size of your document, and in principle you can vary it, you can play with it just to avoid hitting the toasts. Not compulsory, not mandatory fields are there, and I calculated performance. It's not very fair because we reduced the volume, and when I equalize them, at least the speed on 6scan with iLike is similar. It is made that to avoid toasting of the patient, and here it is being toasted, but the speed is approximately the same. They have the equal weight. So we would pay dozens of percents to get the access to attribute. We will pay also for disks. On the other hand, we get this free scheme, and maybe the price of this freedom is really worth it. For instance, we work in a complicated subject matter area where all problems add up, and we're ready to pay for it. And besides that, medicine doesn't have such big data and big loads, but the complexity of the subject matter area makes a big headache for us. Our next round is to see how to paste and how to insert and modify JSONs. We already know what is JSON, and we decided to use it in our system. We know how to create primitive lines. Let's take a look at other functions of JSON and how to manage difficult situations when we need complicated migration or complicated entities. We already considered this. In Postgres, there is a function which allows to assemble JSON objects. For instance, JSON build objects. It takes pairs of keys and values, any primitive JSONs. It can be lines, numbers, or both. Or it can be enclosed JSONs. For instance, we can write foo with the value object in the line, mar. Oh no, we should cast it. Now it has become enclosed. To create arrays, we have a helper JSON array which takes over the set of values of this array. All these functions can be combined. For instance, it's possible to create an object which name will be an array from object, and then it's going to be deployed to an array with only one key. Also, it can be passed over to with the enclosed JSON objects. A very useful function, JSONB strip nulls. If you build some basis for data update, or you gather objects from JSON tables, or if you integrate a GHub, you receive a new JSON from REST IP. In Postgres, we have district nulls function, which cuts out all nulls, all zeros from a normal object. We had it under gender key, and it was also cut out from the address. The only thing we have, the only objects and external arrays. The keys are being cut out, but objects are still there. You can clean them using case, but that's a task under a star, so if you may. Let's consider an example when we want to create objects from legacy base or from a third-party external source where all data are flat. What we propose is a database and weekly cut of changes in the doctor's register in this United States. You can take a look at all columns, and in this table we have around 330 columns in general, in total. It's clear that the data dissemination is huge in such tables. There are a lot of arrows named with underscore. A row to JSON useful function allows to get together a JSON object very quickly and in a beautiful form by cutting out all unnecessary elements. And the input table with 330 columns would turn to a table with only 25 keys. So you can see how scattered and dense, how scattered and scarce data are. We can place this data to our domain area using this tool. One of the most useful statement is statement 2 sticks. It merges two objects in an interesting way. From the left and from the right are arrows. As a result will be also an array. And if on the left we have an object and on the right an object, then the resulting object will be a merger of two objects. If we have at least from one side we have an array, the object which we pass over will be concatenated to this entity. As a result, the array is the first. It's the result of this merger operator. The same way the other way around, but just the object comes in the rear, comes last. We can merge also lines in the array, and then these will be in the end. The only thing, it's not possible to merge lines with objects, otherwise it will come to an error. Also useful statement minus, which allows to cut out keys from objects. It's very useful too. For example, A and nested keys, you can cut out A key using this statement. Also, statement minus can take text array with enlisted keys to be deleted. We cut them from R nested and R we cut, and now we have an empty object. For embedded, if necessary to cut out key somewhere inside, we use hash minus statement, then the path, and that's going to be the path using which we will make the cutout. We cut out nested R, and only nested BC is in the return, is in the output. No microphone. You mean this example? You can take it on top of the strip nulls. You can clean it separately. No microphone. Microphone is off. There are other functions. For instance, merger is not convenient, you want to go deeper, you want to insert something in a deeper level, JSONB set function takes the object which will accept the insert, then the path and the value. And the path can be long, and then you should insert something deeper. JSONB insert, another thing, it's a good helper. It helps to insert, and if there was something already in the path, it can be rewritten. A set can be rewritten. If we just insert it once and try to insert once again, there will be an error that it's not possible to insert this thing. Let's consider a real case. We work with the medicine industry, and there are a number of statistics, and we have condition resource where all diagnoses are stored of patients. These diagnoses are under the coding key. We see that body mass index 30 plus means obesity, and so we see the array, and other values could be there. This is a huge medical handbook using which everything can be coded. For example, we decide to move from Nomad to ACD10, and we want to mark all sinusids which has been coded with Nomad using a different reference book. So it's a big query, and the main idea is that the resources are searched for with the coding containing interesting code, and the resource has the same value merged with the new code. And in this way we get the array, and we we supplement it with our new value, and we use this new functionality of merger with arrays. Let's take a look what happened as a result. So these are sinusitis and chronics. And now I turn it to Nikolay. We looked how to operate JSONs in the database using specific statements or some composition. You can reach out every element, you can change and use key operations of merging. And let's take a look at search now. Since we have arrows, these arrows can be used in V. Here we can take and find all encounters for a specific patient just by using the element and by writing a predicate. Afterwards, we can index this statement, this phrase. Inside the index we can write a phrase which can be indexed then, and later on this piece will be used for the search. Map index scan, and the search speed will be as if it was a column. Our first helper is the functional index. We also said that we can cast it. If we had a timestamp, we can cast, we can get a line or cast a data type in Postgres, and to make a classical trick in the same way with data, we can index this phrase, immutable data, which is dependent here, and Postgres will not allow you to build an index and will tell that it's invalid. We just take it, index it, and then this search goes through this index. Everything as usual. deeply enclosed data, and if somewhere on our way we meet arrays, then it is harder for us. We should forecast what would be the value if we go through arrays, arrows. We cannot take the array and say that we can embed it. In this case, we can get used of the inclusion statement for JSONB. It takes a look whether the left part can be included in the right part. It's quite a smart way, smart statement. This one is not included, this one is included. And the same way we can check the inclusion in the array of not full object in the form of a pattern matching. And it works quite deeply. It checks whether it's included, the object is embedded, so we can build up a very complicated statement. Another statement, a question mark, is just about availability of specific keys in the field. Xendum is the list of keys, whether it's there or not. So our query with embedded array can be written in the following way, and the object which we are matching inside, independent what will be its position, it's going to be matched. We don't think about arrays anymore. Next comes even better thing. We have GenIndex support out of the box, especially for this inclusion statement. We can say that we want to build GenIndex above observation for a whole document, and it's going to serve all possible queries for inclusion. Only one index for all. That's wonderful. We have optional statement class JSON pass ops on defaulted JSONB ops. The difference between them is that the default operator, the default statement, speeds up the search. It turns on the question mark, and the JSON pass mode does not switches them on, and just switches on the path value. We can see that we pay quite much for this opportunity. The default is 100. Table is 100 M and 17 M for the default cloud, and with the default it's only 9 meters. If you are not about to see whether keys are included in your document, you can select non-default statement of your class.
So we'll look at it, and we see that we use the default operator in this case, and we see that this is the index it is used, and here it's chosen the smallest one, JSONB path. Perfect for the boards from Postgres 4, JSquery function that provides us the predicate language to describe different criteria through search through the JSON. So you just search for JSquery, Google it, and you can check up very good documentation with rich language, with description, with figures, percentage, dollars, any enclosure can be found. You need to put it all together because it's not the box. What we have recommended to you, it's there. And then beautifully you can write down when you find all the observations and using this path, and any array can be found. The code is equal to such and such. Subject ID is such and such, and here's the value. Further on, you can find the operator class with jsquery, which serves jsquery queries. And we can create the index with that, and this class of operator supports the operators for switching. So you can create one index if you use JSON pass value Oops. Here's JSON-query. We can compare. There's something average with the size, but it's much richer. So we can have a look. We can look up with an index and with a very complex. So one index will cover the class of, not with all JSQuery, but with quite a long list of queries can be covered with it. So for us to understand how it's operating, there is a helpful tool, the option, that shows us that sometimes we do not have the statistics, sometimes you have to do it manually. So here we see that in the beginning it helps us to look up with the subject ID, and only then it changes to less selective one with the coding. Since we do not have the statistics, we have some hints, and manually, magically, you can work with order, we switch in and switch off. So, and with these hints, you can look at it and see how your query goes. So it's in a recheck list. So if we stop all that, then the usual operator will switch in and will use the JSON-query. So if you have extension JSQuery, but it will not use the query for the key search. We have something in repository, the extension that we created for ourselves that allows us to choose a certain path done by the JSON, and it has some aggregations and conversions. This is our specifics. This is a complex functionality, and the index, the same data, the same JSON-query, we cannot create, and we can follow the paths, which is a tricky one. So there is some extension in JSON-query. So we can have a look if something like this happened to you. So how much time do we have left? Nothing's left. We have only 10 minutes left. Some analysts come and they say, we don't want to work with JSON, give us the UIT, and we cannot create JSON, so we cannot draw it, those columns. We need something more simple, so we can use the flat view, some flat representation of your originals, and take this view, and if it's materialized, then you can create the index and to create the illusion for your analysts that they are working with the flat tables. And when everything's updated once in an hour or during the night, then you can materialize it. Then Postgres Pro specialists, they're working on a new version of XQuery. We have JSON functions, and there is a whole chapter which is specifically written for the JSON, how it works. Then there is a forward Postgres Pro, and it has to be the part of the Postgres Pro, JSON paths, including the JSON paths language, which is more clear than in JSON-query. But this is going to happen in the near future. And the last thing that I wanted to speak about, if you do not say storage in JSON, still it's an interesting thing to form complex answer on the side of the database. I will explain you what I mean. This is a functions wrote to the JSON, which creates the functions to JSONB. So on that line, you call up for JSONB, and it creates this line into JSON. What we have said is 3 tools, it can be cleared, and we have some JSONB aggregate function, which will put it in a JSON array. If we go to information table with the columns, we group it into tables, and with that we create the array of the columns. So is it clear what happens? So the same functions with JSON aggregate objects, where we can put the columns not only in array, but in the object with the key to the name of the column. And then we can minus or column name, so we don't see it twice. So instead of the array, we have, for each table, we have the object with the key of the name of the column and the rest of the parameters. So we can play with it, and in the end, there is a funny query, the cth, that shows the structure of all your tables with all the columns. And first we choose all the tables, then the columns, then we go into PG class to see the size, and then we use this table size magic function and send the query. And with one query, we have a huge JSON document with all the names of the columns. This is the dream. Everything is in JSON, the parcel at the side of your application. You receive it and eat it up. With JSONB aggregate and the road to JSON, from the server you can bring back the complex and tricky answer and not just a flat table. Usually this logic's been done in the application layer with a few queries and then mixed it up and put it into the applications. But with the GitHub in Postgres, you can bring it at one and the same time. It's more effective, I think. And with that, we have only 5 minutes left for questions and answers. So no microphone. Was it in your experience the keys with zero, with null? The JSON puts the nulls, the empties away. So here's the different worlds: closed and open world. The world, when we use JSON, when we don't know it, it does not exist. So we just ignore this key and we just disable it. But sometimes we want to show that it doesn't exist. This is why maybe it's not good to use the null. Maybe we should. Why don't we know the name of the patient? Why don't we know the date of birth of the patient? Does it mean that if we don't know it, simply don't know it, or if we cannot retrieve it? It depends on your interpretation. For instance, in the table, null sometimes is useful information. Then it means that it is the information. The absence of the information is the information, that it's not there. So if this data remains, the null, they interfere. Well, we need those nulls in order to show them this information as absent. So in JSON world, they say the JSON, they say there should not be empty arrays and objects, so the nulls have to be deleted because they take up the space. Show us again the coordinates where we can see these examples. The link will let me copy this, and then I will just enlarge it, and so you could see it, because here's the fhirbase. That's the name of the International Medical Center, and that space, it's an open database /master/class. This is on GitHub, so you can write Dr. Compose with a JSON-squery and json-knife, and then you can copy that and use it. If you want to use Enigmax, then let us know. We'll send you 10 lines that you could be active for the search in interactive mode. Do you have some other examples when we can retrieve the object, the complex one, and the vector of the attributes when you perform the join of two tables? For instance, the name of the patient and his email and other information. Yes, inside of your table you have the number of visits, and of course people want to know if there's information about the patient and it's insurance information of this patient. With JSON aggregate, you just join the tables and you put all the instances together, and you have the whole tree of the patient with the name and the number of his insurance and so on. You keep them in different tables, but because of this merging of the JSON AKG, then you can increase this JSON and retrieve the information from different tables. The visits of the patient is located in different tables. But this data set, which is loaded as a standard file, let me show it. This is modelized the instance, a medical instance. You can see how many of them are, more than 200. And this is a medical domain which is modeled with enhanced aggregates that we use. We do not create our own scheme. Or with one table, when the attribute is deep below, if I want to select it and I want to put the attribute up. Yes, you can put it up with the help of the arrow and then to show the parameters. I'm not quite understand your question. So there is a table in JSON, there is an attribute. I want to retrieve this attribute. I want to select it, so I want this to be effective, but it's mapped to something else. Yes, you do it through the merge, you do the JSON build attribute and merge it into the document that you had before, the original document. Looking at all that, I want to ask you a question. Sometimes it's not correctly operating. So what are the ways to do the troubleshooting? Is it some sort of tool that can be used? Well, there is not a big difference in simple Postgres. If you can use the arrows. It looks like DSL. Inside the DSL there was one more DSL. It's very mysterious. Are you asking about JSON-query? No, it looks like a DCL on SQL plus DCL. It looks very, for the knife fits and for the beginners, it looks very mysterious. If you look at the Lego code, it's not operating. How can you solve that? Maybe the helps or the tools for the tuning. You cannot write the old tuning through DCL. These are predicate languages. Or in SQL, the description is given in the jsquery. For tuning the indexes, we have some additional functions, but if you face some trouble, you just write a letter to the person who developed it, and it's hard to say that we face something extremely mysterious that we couldn't solve using the public information. We have a PostgreSQL Facebook page, and we have 3 channels on Telegram, and some developers who actually did it and wrote the codes who make it work. They are available. And Alexander has been writing that as Postgres professional. You can address these questions to him, or you can actually come up to him personally and ask this question. Thank you for the masterclass and for the merging of the objects, including the something that was enhanced, some very products, functions, when the keys in the objects are similar. You merge what you implement, what you enhance, with the same object which has been enhanced. Maybe it's not so clear, but let me show you on the example. So it's not in the box, you have to write it, right? This one. Here, if we look up closely, you see the set, and apart from that, you take the original coding and you merge this with something new. So you need to write these statements deep inside. So you need to merge it and then wrap up those merges. And there are also functions that help you to open the array of relations, segregate it and bring it back. So we aggregate the keys of opened objects, but the performance, the production, we wish we could have it. We could make it done faster. It will be faster if it's a tricky transformation that we use this PLv8 in JavaScript, and these that are imported, and with the help of Oleg and Python and other languages. PLv8 is JavaScript, it's original language, so you can write a tricky message and turn your object upside down, for instance. If it's a very tricky transformation, then you can use the procedural language. We are in the clouds, so when the terabytes are getting closer, then you're getting sad. Hundreds of gigabytes are being used. The quantity of the lines, the size of the clinic, so the size of the staff. They have like millions of or tens of millions of patients. They have hundreds of visits, the billions of observations. So the average clinic or the hospital can be hundreds of patients, maybe less data, but still. My question was partially asked already with administration point of view. You talked about the developers, the use of this information which is presented in your presentation, but not gigabytes, but in pieces, items. Why is it more important than gigabytes? Gigabytes can be different. And the second, the archi structures, non-evolution views. Have you seen the limitation when the Postgres is finished and the scaling starts? We like Postgres, and we work in the medical field, and we like the transactions, we like the SQL, the full mode of SQL, so this mix of the documentation database and plus the evolution database, the extension of Postgres, this is a good combination. I think one hot Postgres can cover St. Petersburg and Moscow. Only one will become very popular, and this one we have to scale and share horizontally. This is one of the fields that we can talk about, vertical or horizontal scaling. This is the thing. As far as I know, there are many solutions when the sharing can be done in stuff automatic mode, and when we have those clusters. HTTP, we can discuss that, and there are many people that care about the clusters, and Postgres is as an elephant, it makes the correct steps, so it will never fall down.
I told you a little bit about overhead. You will pay dozens of % for disk storage. And it's up to you to decide what is more important for you. For example, the standard I showed you, 200 entities is described. When we started it 4 to 5 years ago, we generated flat tables, and we arrived at 3,000. Just to retrieve one resource, it costed dozens of joins, and of course it died. And we decided that JSONB is more interesting. Without speaking about the openness, many extensions can be added on the fly, which is also very important. To add a column to a good loaded table, it's not trivial, especially on the fly. Well, you receive new information with one field and you have to put it somewhere. Everything should be measured, should be considered. A demo for 1 terabyte on hardware fixed, we did it. Everything was in cache and was on the fly. I think on the good hardware it will work even faster. But that's not a question to me. And Postgres Pro, you can hire them and they can help you. And is it possible to support associations? Can you make a reference from a line to a different object? Yes, you can use the ID. You can make it. Yes, to make a foreign key. Yes, it's possible. I think, but well, I don't like foreign key in general. I don't know whether it's possible to make foreign key on. You can place a constraint maybe which will behave like a foreign key. If you really want it, you can do it. JSquery can have an interesting effect. You can use it in a constraint and the basic scheme you can guarantee inside your environment. We omitted the validation point of JSON. We don't say that there is no scheme. We don't know it, and we don't want to rigidly fix it. The scheme and structure, data has the scheme and the structure, but it's wider. And what about the automatic scheme? Yes, we discussed it. If we try to do it on C to implement the JSON scheme, if we find a good engine, we can do it. I considered many things, but many things make to do everything from scratch. Theoretically, it's possible to make it on C and place it as a constraint, but no one did it. If you want, we can do it together. I already wrote 3 realizations of this scheme, but not on C, unfortunately. Okay, thank you very much, guys. Well, we are in Telegram chat. You can find us on GitHub. If you have any questions with the operation of JSONB, please, we are at your disposal.